Almost everything radiates energy, even you. The sun radiates different forms of electromagnetic energy, but especially visible light. These wavelengths enter the Earth system, but then what happens? Let's look at this diagram from NCAR Distinguished Senior Scientist Kevin Trenberth and colleagues to find out. The diagram represents the energy budget from 2000 to 2004. It's important to know the time represented because incoming and outgoing energy in the Earth system actually vary over short and longer time periods. Daily, seasonal, yearly, and decadal variations in cloud coverage, ice, El Niño, volcanic eruptions, the sun-solar cycle, and more can alter energy absorption and reflection. If you study other energy budget diagrams, you'll likely find slight variations as a consequence. Also, a small percentage of trace gases in our atmosphere trap heat. We call this phenomenon the greenhouse effect, and it actually makes our Earth inhabitable. Greenhouse gases, like carbon dioxide and water vapor, have an enormous ability to absorb and re-radiate energy. Without it, Earth would be 0 degrees Fahrenheit on average, or negative 18 degrees Celsius. But because of the greenhouse effect, Earth is about 58 degrees Fahrenheit instead. The amount of carbon dioxide has increased steadily since measurements began. Today, increasing greenhouse gases are contributing to an enhanced greenhouse effect. By the time the sun's energy reaches the top of Earth's atmosphere, it enters at approximately 341 watts per square meter, but bright white clouds and other shiny particles in the atmosphere reflect a portion of this energy back to space. At Earth's surface, another portion is reflected and exits. We call the reflectivity of a surface its albedo. Albedo is the reason people wear light colors in the summer, to reflect rather than absorb solar energy. Added together, nearly 30% or 102 watts per square meter of the sun's energy returns directly to space. The remaining portion of the energy is absorbed by the atmosphere, by things like ozone and dark soot particles, and at Earth's surface. Together, these absorbed portions of energy equal the other 70% of incoming radiation from the sun. To ensure Earth doesn't overheat by constantly absorbing more and more energy, the Earth emits infrared long-wave radiation, heat, back to the atmosphere. It also emits energy through thermals and evapotranspiration, where energy evaporates water on Earth's surface and then releases that energy to the atmosphere during condensation. Take a moment to add up the incoming and outgoing radiation at the top of the atmosphere. Are incoming and outgoing energy in balance? You need only look to what's happening to greenhouse gases to see the causes of current imbalances. When Earth's energy absorbs more than it emits, what are the impacts, and where in the Earth system does the extra energy go? How certain are scientists? Take some time to understand Earth's energy budget. Next, research credible sources to find out the impacts of an energy imbalance. And finally, find out what we know about where the excess energy resides.